Alrighty, hello again. So to continue where we left off, we're going to be looking at the quantum mechanical model and just talking a little bit about what that means and how to solve problems using it. So electrons are located in specific energy levels, which you already know. You know that those energy levels go around the nucleus, but there's no specific path around the nucleus. They're not always perfectly circled around there. They don't have to go a certain direction, which as we learn about quantum numbers, you'll learn a little bit more about. There's a certain path they follow, but it's not an exact path, okay? Along with this quantum mechanical model estimates the probability of finding an electron in a certain position. So we can estimate where about an electron might be in its separate orbitals. This brings us to the Bohr model, which you've already learned about in some way. We called it the orbital diagram before. So the Bohr model is that electrons orbit the nucleus in circular paths of energy, which are called energy levels. So they orbit the nucleus in what we call orbits. Okay, remember back to last unit, we drew these when we had something with 10 electrons. We would have 2 in the first orbital, 8 in the second one, to have a total of 10. So this was proposed by German physicist Max Planck. He proposed the relationship between a quantum of energy and the frequency of radiation. Okay, so we're now connecting energy to frequency. We previously talked about wavelength, but we're now looking at frequency, which is E equals hv. Okay, E equals hv, where E is energy in joules, J is joules, that's something we're measuring energy in. V is the frequency, which we've talked about before, and H is what we're going to be calling Planck's constant. Okay, Planck's constant, and you will need to know Planck's constant. Planck's constant is 6.626 times 10 to the negative 34 joules times seconds, or joules over seconds negative 1. Okay, so we're going to be using this equation to find energy of a system based on its frequency and Planck's constant. Just some other terms you need to know is a quantum. A quantum of energy is the amount of energy required to move one electron from one energy level to another. So in our POGIL we did a couple days ago, you saw that you could move energy from one level, or you could move an electron, from one level to another. And you had to either gain energy to move away or lose energy to move closer to the nucleus. A quantum is that amount of energy that's required to move the electron from one place to another. Connected to this is what we call a photon. A photon is a bundle of light energy that's emitted by electrons as they go from higher energy levels to lower energy levels. So as we move up an energy level or down an energy level, a photon is emitted, and a photon is shown through light. Okay, think about what a photon is and how that connects to our phenomenon we're focusing on this unit of why electrons emit different colors. Okay, we are going to do a little practice problem here. So when a calcium salt is heated in a flame, a photon of light with an energy of 3.2 times 10 to the negative 19 joules is emitted. What is the frequency of this light? Okay, we're going to solve this together, so let me go ahead and pause us and bring us back to our whiteboard. Alrighty, hopefully you can see this whiteboard okay. Sorry, I don't have a classroom right now, so I'm just using the workroom. So in our problem, it tells us that the energy given is 3.2 times 10 to the negative 19 joules of energy. Okay, so that's what we're given, 3.2 times 10 to the negative 19 joules. We're using the formula energy equals hv. Remember, E is energy, H is what we call Planck's constant, and V is going to be our frequency. We are looking for our frequency, so our V is our X, or our question, and we know Planck's constant. It's just something that's always the same, and Planck's constant is going to be 6.626 times 10 to the 34th, to the negative 34th, joules times seconds. Okay, so we're going to use these, EVH, and just plug them into what we were given. So we're given E, so we have 3.2 times 10 to the negative 19 joules equals our 6.626 times 10 to the negative 34 joules per second times our frequency, which we don't yet know. It turns into a simple algebra problem of getting V by itself. So we're going to divide by Planck's constant on both sides. Oops, that's an S. Notice we have joules on top and joules on bottom, so joules is going to cancel, leaving us with S negative 1. And if we divide these out, you will get the answer for frequency. And our final answer is going to be 4.829 times 10 to the 14th. Sorry, all this stuff is in my way. S negative 1. And we learned in our last video that S negative 1 is the same as Hz, or Hertz. So it's a basic plug and chug type of problem once you find out what you're looking for and what you have. If you have questions on solving this type of problem, make sure to reach out. We will be doing a practice worksheet on this first thing next class. And now you will just have more time to work on your homework if you still needed that. Otherwise, you guys are maybe good for today, maybe a couple more notes. I haven't decided yet. Okay, bye.